Hey everyone, it's that math magician, and on this video we're going to take a look at how we can solve some right triangles. Now, just to recap what that means, to solve for a right triangle means that we want to solve for the missing sides and the missing angles in that triangle. And we have a lot of tools and resources that we can use to solve for those unknowns. And so for this video, I want to sort of encompass all of the different things that we know for right triangles and show that we can use that to solve for those right triangles. Now, before I jump into some example problems, I think it might be beneficial to go over all of the tools and resources that we have. And we have a lot. Looking here on the left column, this is all of the tools that we have to solve for a missing side. Now remember, we can use sine, cosine, and tangent to solve for a missing side. And remember, sine of theta equals opposite over hypotenuse, cosine of theta equals adjacent over hypotenuse, and tangent of theta equals opposite over adjacent. And remember, those sides all rely on this reference angle here, right? That reference angle is another angle in that right triangle besides the 90-degree angle. Now, we can only use sine, cosine, and tangent when we at least know one angle and one side. That is the only time that we can use those three trig functions if we have those two parameters, one angle and one side in that right triangle. Now, we also have another tool to help us solve for missing sides, and that is Pythagorean's theorem, which is written right here. Remember, a squared plus b squared equals c squared. And we can use Pythagorean's theorem when we already know two sides of that right triangle and we want to find the third missing side. So those four trig functions that we have here, those allow us to solve for a missing sign, depending on what information is given in that right triangle. Now, that same idea is going to be applied to when we're solving for missing angles. For missing angles, we can use sine, cosine, and tangent again, but we'll have to use what we call the inverse of those functions. Inverse sine, inverse cosine, and inverse tangent. We're able to solve for a missing angle in that right triangle when we know two sides of that triangle. Now, again, this is for solving for an unknown angle in the right triangle. This is kind of excluding that 90-degree angle. We're trying to find our reference angle, so that's when we can use inverse sine, inverse cosine, and inverse tangent. Now, let's say we do have a right triangle, and we already know two angles. Let's say I do know the 90-degree, and I do know another angle in that right triangle. Well, we can remember the fact that our triangle angle sum theorem tells us that all three angles in a triangle do add to 180. So if you do know two angles, you really don't need to use inverse sine, cosine, or tangent. Instead, you can just subtract 180 from those two angles that you know. Now, this is a lot of information, right? This is a lot of tools and resources that we can use, and it can get kind of confusing to know when to use one or when to use the other. So as we move through these examples, I'll highlight the facts of what I know and which tool I'll be able to use, because in most situations here, there's only going to be one right tool to use to start us off with. So let's go ahead and look at our first example here of a right triangle, and we are going to see, can we solve for this unknown side of x? Now, I see that I do have an angle that I know, a reference angle that is 47 degrees, and I do already know one side. So looking back up here at my tools that I can use, I know one angle, I know one side. This is definitely going to be a sine, cosine, or tangent problem. We just have to figure out what sides we have. Well, looking at this triangle, I'm going to go ahead and label the sides using this angle as my reference point. So to do that, I'm going to draw to the opposite side here. I know that this side CB is the opposite side. I see that I have my 90-degree angle here. Remember, the 90-degree angle points to your hypotenuse. So I know that 3 is the hypotenuse, which leaves x as the adjacent side. So I have adjacent, I have hypotenuse. The only trig ratio that uses those two is cosine. So now I'm going to go ahead and set up a cosine ratio to allow us to solve for x. So I'm going to go ahead and copy that down. Cosine of my angle, well, my reference angle here is 47 degrees. That equals our ratio of sides, adjacent over hypotenuse. Well, my adjacent side is x, my hypotenuse is 3. So now I have a cosine ratio set up. I have one variable in there, that adjacent side, that's x. I can definitely solve this problem. Now remember, to solve at this point, we put the left side over 1, we cross multiply, and we want to solve and isolate for x. So when I cross multiply here, I will end up with x times 1. Well, x times 1 just creates x equals, cross multiply the other two parts, that will become 3 times cosine of 47 degrees. So I know that that right there is what I need to enter into my calculator. If I type in 3 times cosine of 47 degrees, I'll be able to determine what x is approximately. Now remember, you can use a scientific calculator for this portion. I'm going to go ahead and use this free online scientific calculator from Desmos.com. It's very nice and simple and easy to use, and it allows us to just throw in all of that expression in at once so we can figure out what x is. So I'm going to go ahead and type in 3 times cosine of 47 degrees. So I type that in and I see that 3 times cosine of 47 degrees equals approximately 2.046. So 2.046. And we have now determined that missing side of this right triangle using cosine. And again, the reason why we use cosine is because we were given one angle and one side. When you're given an angle and a side, and you're trying to solve for an unknown side here, it's either going to be sine, cosine, or tangent. Let's go ahead and jump to another problem now. Let's look at this right triangle. And I'm looking at this right triangle, and again, first things first, I want to look and see what information do I have. Well, I see that I do have an angle here that is 57 degrees, and I do have a side that I know its value of. So again, very similar to the example we just covered, I have an angle, I have a side. It's either going to be sine, cosine, or tangent. So let's go ahead and look at this and label the triangle based off of the reference angle that I have here. Well, if I draw to the opposite side, I see that 10.8 is my opposite side. I trace the right angle. Remember, the right angle points to the hypotenuse. So that means that x over here is my hypotenuse. So again, I really don't even care that this is the adjacent side because it has no information that I care about. But I can see that this is the hypotenuse and this is the opposite side. The only trig ratio that uses opposite and hypotenuse is our sine ratio. So I'm going to go ahead and set that up. Sine of my angle, which is 57 degrees, equals our ratio of two sides. Remember, sine, opposite over hypotenuse. Well, my opposite side is 10.8. My hypotenuse is x. Just like the previous example, I have my sine ratio set up. I can now solve for x. To do that, I will put this left side over 1. Again, let's cross multiply. Let's isolate our x variable so we can solve for its value. I'm going to cross multiply here. I'm going to end up with x times sine of 57 degrees equals, cross multiply the other side, 10.8 times 1, which will just be 10.8. Now I don't have x by itself already. Because x was in the denominator, I will have to do an extra step here. And that is, I need to remove the sine of 57 degrees. So since they're multiplying each other, the way I will remove that is by dividing both sides by sine of 57 degrees. When I do that, the sines on the 57 degrees is cancel on the left side. So I'm just left with now that x equals 10.8 divided by sine of 57 degrees. Again, this is the time that you want to break out your scientific calculator and you want to enter that expression in to see what x is approximately equal to. Now, if you want, you can pause the video, try to enter that in, and then press play and see if you get the same answer that I do. So I'm going to go ahead now and type in 10.8 divided by sine of 57 degrees, and I see that x equals approximately 12.878. That is how we use our sine ratio to solve for an unknown side when you're given, again, one angle and one side of that right triangle. Let's go ahead now and jump to another example. This is our third example. We have two more that I want to cover. And let's look. I know that I'm trying to find out this missing side here of x. I see that I'm given an angle and I'm given a side. Again, when you are given one angle and one side in a 90-degree triangle and you're solving for an unknown side, then it's either going to be sine, cosine, or tangent. Well, to figure out what I need to use, I'm going to start labeling my sides. That is the opposite side. I'm going to trace my 90-degree angle that points to my hypotenuse, which means x over here is the adjacent side. So I have adjacent, I have opposite. The only trig function here that uses opposite and adjacent is our tangent ratio. So let's set that up. Tangent of my reference angle, which was 41 degrees, equals opposite over adjacent, which will be 4 over x. You guys are hopefully getting familiar with this. My tangent ratio is all set up. I have one variable. Now we just need to isolate x. So I'm going to cross multiply and solve for x. So x times tangent of 41 degrees equals, cross multiply the other part, 4 times 1. Well, 4 times 1 will make 4. Again, I want to isolate for x. X right now is multiplying by tangent of 41 degrees. Just like with the other problem, I need one extra step since my variable was all alone here on the bottom of that fraction. So I want to remove tangent of 41 on both sides by dividing by tangent of 41 degrees. I do that, the tangents on the left cancel out, and I'm left with x equaling the quantity 4 divided by tangent of 41 degrees. That right there again is what I can enter into my calculator to figure out what x is approximately. Again, pause the video, try entering that into your calculator. Let's see if you get the same result that I do. So I type in 4 divided by tangent of 41 degrees, and I see that x is approximately 4.601. So again, we have solved for an unknown side of a right triangle using our tangent ratio. We use tangent here because we did have one angle and we had one side. Perfect. All right, let's go ahead now and look at our final example here. Our final example here does not have an x variable. Instead, here we want to solve for all of the unknown parts here. So what I'm going to do is I'm going to go ahead and label these sides with different variables so I know what I'm going to be solving for. I see that AC does not have a number here, so I'll go ahead and label that with X. I see AB, the side AB does not have a side there, so I will label that with Y. And then I do see that there is a missing angle here, which I will label as theta. Now, we need to figure out what we can use to solve for some missing sides and missing angles. Now, I see again that I'm starting off with an angle and a side. So if I want to solve for x or if I want to solve for y, I could just go ahead and use sine, cosine, or tangent to solve for one of those missing sides. And that's what I'm going to start off with. So I'm going to go ahead and label this side using 28 as my reference angle. So that means x over here will be the opposite side. I'm going to trace my 90-degree angle. It points to my hypotenuse. I see that y is the hypotenuse, which means that 6 here has to be the adjacent side. So now I have to make a decision. What do I want to solve for first? Do I want to solve for x or do I want to solve for y? Well, I'm going to go ahead and just use y as the first one that I'm going to go after. So y is the hypotenuse, 6 is the adjacent side, adjacent and hypotenuse. That means we are going to use cosine. So cosine of my angle, 28 degrees, equals our ratio of sides. Remember, adjacent over hypotenuse. So I'm going to go ahead and write 6 over x. Now we just need to cross multiply and solve for x. So let's go ahead and do that. X times cosine of 28 degrees equals, we'll cross multiply the other side, 6 times 1, which is 6. Again, I want to isolate our x variable, so I will divide both sides here by cosine of 28 degrees. By doing that, I will end up canceling out the cosines of 28s on the left side, leaving me with x equaling 6 over cosine of 28 degrees. Let's throw that into our scientific calculator and let's see what we get for x. So 6 divided by cosine of 28 degrees. We now know that x equals approximately 6.795. 6.795. We're dealing with inches here as our units, so I will also write that that is inches for x. So there we go. We've solved for x. Now, we probably want to solve for y. Oh, that we did not solve for x. Look at me making a huge mistake as I worked through this problem. I wrote down x as our variable, but remember we were actually solving for y. Now, a better YouTuber would probably edit that out, but instead for me, I'm just going to go back through here and I'm going to erase all those x's and change those to y's, because remember, we were solving for y. Remember, y was the variable we were solving for, and that is what we found out. Now, we know what y equals. Y equals approximately 6.795 inches. Now, the only side we don't have left here is x. And if I really wanted to, I could do this all over again, right? I could solve for x using either tangent or sine. I could set up a similar equation here, and I could solve for that. But since now I know two sides of this right triangle, and I'm trying to find the third side, I think this is actually a great time to break out Pythagorean's theorem and show you how we can use that as a replacement from sine or tangent. Again, there's nothing wrong with using sine or tangent again, but since I already know two sides, let's just go ahead and use Pythagorean's theorem. So I'm going to go ahead and set up a squared plus b squared equals c squared. Now remember, c squared is always the hypotenuse, and we know what the hypotenuse is now. We know that that value is 6.795, and we know that we're going to square that. Now, it doesn't matter for x and 6 where you put them for a and b. They can be put in either position. That part there doesn't matter. So I'm going to go ahead and just write my x squared first plus the 6 squared. Again, it doesn't matter if I wrote 6 squared first and then x squared. We just need to make sure that we are using c as our hypotenuse. So let's go ahead now and start solving this for x. So x squared plus 6 squared makes 36. I need to use my calculator to figure out this. So 6.795 squared is approximately 46.172. Now I'm solving for x squared. So we will need to subtract both sides by 36. I do that, the 36's cancel, so I'm left with x squared. Let's go ahead and use this answer here and subtract 36 from there. And we see that x squared is approximately 10.172. But again, I'm not interested in x squared. I'm interested in x. So to figure out what x is, I need to take the square root of 10.172, which will approximately be 10.172, 3.189. 3.189 inches. That is our remaining missing side of our right triangle. I'm going to go up here. I'm going to write that right next to it. We now know that x is approximately 3.192 inches. Again, we could use Pythagorean's theorem to help us solve that missing side. If we wanted to use sine or tangent, we could have. And I actually would challenge you guys to also try to set up a sine or a tangent ratio. And you should still end up with x equaling approximately 3.192. Now you might think that we're done since we have covered all the sides, but we do have a missing angle here. Now, there are again two ways to solve for missing angles. We could either do an inverse sine, an inverse cosine, or an inverse tangent. Or, since we do already know two angles in that right triangle, I could just subtract 180 from both of those. But since the purpose of this video is to sort of highlight all of the different tools that we have, I'm actually going to go ahead and use inverse here to show you how we can solve for theta, our missing angle at the top. Well, since I'm using this as my new reference angle, I actually need to erase that blue line, and I'm going to need to relabel these triangle sides based off of theta as my new reference angle. You'll notice that when I draw the arrow, 6 becomes the new opposite side, and x over here, which was 3.192, is my new adjacent side. Now, when you're given 3 sides, if you look here, I know 3 sides now. You can actually pick sine, cosine, or tangent to use. It truly won't matter which one you decide to use here. For me, I'm going to go ahead and use tangent, since we do know opposite and adjacent, and we'll be able to see what that missing angle of theta is. Now I'm going to set up my tangent ratio. Tangent of our missing angle of theta equals opposite over adjacent. Opposite side here, our new opposite side is 6. Our adjacent side is 3.192. Since I'm solving for theta and I do know the two sides, I can now switch this problem into an inverse tangent problem. I'll take the inverse tangent of that fraction, 6 over 3.192. Again, we're going to use our calculator. We're going to break that out, and we're going to see exactly what theta is approximately equal to. So let me go ahead and open the calculator up, and we will go ahead and insert. To get to the inverse tangent button, we will click here for inverse tangent. I'm going to type in my fraction, 6 divided by 3.192, and we see that theta is approximately, I forgot the 192 part. Whoops, 192. We see that theta is approximately 61.987 degrees. 61.987 degrees. Now, you might be wondering to yourself, why does this angle here have decimals when none of our other angles have decimals after it? And the reason why is because this side of 3.192 was an approximation. So since I approximated that side, this angle here that we're using or trying to solve for will also end up as an approximation. Now, this is one way you could solve for the angle, and I showed it to you just because I wanted to go through one example of inverse. But remember, a much faster way of finding theta, if I already know that this angle is 90 and this angle is 28 degrees, is just to take 180 degrees and to subtract 90, to subtract the 28 degrees. If you do that, you'll find out that theta is exactly 62 degrees. Again, I would probably use this method since I already know the two angles, but I wanted to do one inverse problem with you just to show you that it can be done both ways. And this angle here does approximately equal 62 degrees. So there you have it. For our final example here, we solved the entire right triangle, and we used every single tool that we know. We set up a trig function to solve for a side. We used Pythagorean's theorem to solve for the other missing side. We used inverse trig to find a missing angle, but really we could have just subtracted all of the angles we knew from 180 using our triangle angle sum theorem to also find that same angle. But this is the power of those tools. When we're given a right triangle, we have a lot of ways and methods to solve for missing sides and missing angles. It's just up to you to determine which tool is best. All right, guys, it's that math magician, and I'll see you on the next video.